Now we summarize the discussion that we have done about the RAN splits. Now as we move towards the higher level splits on the front haul, we can see that the data rate requirement decreases, and at the same time the latency that is allowed on the front haul, it increases. So we can have higher latency. And as we move towards the lower level splits, we can see that the data rate on the front haul increases, and at the same time the allowed latency is decreased. Now these higher level splits are useful for the coverage use cases, because in the case of coverage use cases we have large cells in which we have a small number of users, and these users have low data rates, for example in the rural areas. And since we have large cells, the distance between the base station and the CU/DU is also longer, but the data rate and the latency requirements on this link is less. So either we can use a microwave link or we can use a cheap optical fiber in order to cater for these data rate and latency requirements. And then we have the capacity use cases. The capacity use cases are used in the dense urban areas where these cells are very small, and since these cells are very small, the distance between the base station and the CU/DU is also less. But on this link, we require higher data rates and we can allow very low latency. So that means that on these small links, we can use a very expensive fiber in order to cater for the requirements of the data rate and the latency. Furthermore, since the majority of the functions are virtualized at a central location, so we can have more virtualization benefits. And since there are very little functions that are there in the RRU, so the RRU is small, and these small RRUs can easily be installed in the dense urban areas.